Hello everyone, thanks for stopping in. Today you're going to be looking at Math 120, section 8.4, and we're going to be doing some more geometry. First, let's start off with an example. So it says Adelaide plans to fertilize his grass and his lawn. The shape of the property is shown in the image below. Alright. One bag of fertilizer costs $29.95 and covers 5,000 square feet. Determine how many bags of fertilizer Adelaide needs to buy and the total cost of the project. Alright, the first thing I notice is we've got some values, and it gives us the lawn. First thing I check is everything in feet? Looks like everything is in feet, right? All the measurements are in feet. That's good, because the question gives me information in feet. So I always want to make sure my units match up first. Now, I'm trying to fertilize the grass, right? Well, not me, but Adelaide. Trying to fertilize the grass, right? Now, there's a few things I'm not going to fertilize. The driveway, not going to fertilize that, right? The house, not going to fertilize it. The pool, not going to fertilize it. The rose garden, not going to fertilize it, right? These are different parts than the lawn. So if I want to know how big the lawn is, I need to remove these other objects here. So we can get the overall property. So we can get the property. We can get the pool. We can get the house. We can get the driveway. And we can get the garden. We're trying to find the size of each of these locations, right? First, the property. It's a rectangle, right? And it's 150 by 180. So the area of the property it's a rectangle, so it'll be length times width. And it'll be 150 times 180, which 150 times 180, 150 times 180 gives me 27,000 feet squared, right? 27,000 feet squared is the area of my whole property. It's 150 by 180. Well, if I know the whole property, I can remove the pool, the house, the driveway, and the garden. So let's do the pool first. The pool is a rectangle, right? The pool, that's 20 by 30. So 20 by 30. So that has a 600 feet squared area. The pool is 600 feet squared. The house, also a rectangle, right? The house is also a rectangle, length times width. That'll be 40 times 60. 40 times 60 is 2,400 feet squared. So that's the house, right? 40 by 60. The driveway is 40 by 16, and it's a rectangle, right? Length times width. Let's see, it's 40 times 16. 40 times 16 gives me 640 feet squared. And then lastly, the garden. The garden is a circle, right? The rose garden is a circle, which would be pi r squared. Now pi is 3.14, and r, I need to be careful. 24 is the diameter, which means 12 is the radius, right? 12 is the radius, it's half the diameter. 12 squared is 144, right? Times pi, times 3.14, gives me 452.16. So, the lawn, the size of the lawn will be equal to the property, 27,000, take away the pool, take away the house, take away the driveway, and take away the garden. So, we've got our lawn. Oops, 2,700, or 27,000 minus 600 minus 2,400 minus 640 minus 452.16 gives me 22,907.16 2,997.84 feet squared. Right? All the measurements are in feet. So the area of my lawn is 22,907.84 feet squared. So that's how big my lawn is. So I know the size of my property now. Now I'm going to use this part here. That one bag of fertilizer costs $29.95 and covers 5,000 square feet. Now I need to get the total cost. The first thing I need to figure out is how many bags I need. Well, this is going to be a proportion problem, right? One bag covers 5,000 feet squared. So I want to know how many bags would cover 22,907.84 feet squared. It's going to be a cross multiplication type problem, because once I cross multiply, I'm going to get 1 times 22,907.84 will be 22,907.84, and that'll equal 5,000x, right? We know how many bags cover 5,000, 1, right? So how many bags will cover my property? Well, I can divide by 5,000, right? Divide by 5,000 will leave me with x equals, let's see, divided by 5,000 gives me 4.581568. 4.581568. That's what I get when I divide, right? 4.581568. Now, can I buy a decimal number of bags of fertilizer? No, right? So what I'm going to do is I'm going to round up to 5 bags are needed, right? 4 wouldn't be enough, right? I know I need more than 4, so I need 5 bags. I need 5 bags of fertilizer. Well, if they cost $29.95 each, 5 times $29.95. Let's see, 5 times $29.95 will give me $149.75. $149.75. So my final answer, since it's the cost of fertilizing my lawn, would be $149.75. Notice we had to find the size of the lawn first, right? We had to figure out how big is the lawn. And to do that, we had to use the different schematics here, right? How big's the pool? How big's the house? How big's the driveway? How big's the garden? How big is the overall property? And then we found the lawn, and then we did a bit of a proportion to get the actual number of bags we need. So, Adelaide will have to pay just shy of $150 to fertilize his lawn. Let's look at another example. It says Kelsey is purchasing carpeting for a living room. She finds 3 contractors, Alice, Bobbert, and Carlisle. Alice will charge her a flat rate of $500 plus $20 per square foot of carpet. Okay. Bobbert will charge a flat rate of $1,100 plus $15 per square foot of carpet. And Carlisle will charge her a flat rate of $3,300. If the room is 16 by 9, which contractor should she choose? So I see that I have 3 different prices and 1 room size, right? First thing I'm going to find is the size of the living room. Well, living room would be length times width, right? And it's 16 by 9. 16 by 9 will give me 144. It was feet squared. So 16 by 9 is 144 feet squared. So that's the area, right? Now, let's look. Let's look at each contractor. Let's do Alice first. Alice. She charges $500 plus $20 per square foot. So she charges $500 plus $20 per square foot, right? So this will be Alice's cost. You multiply before you add, so we'll do 144 times 20. That gives me 2,880, and I need to add 500 to that, right? Add 500 will give me 3,050 $380 for Alice's cost, right? Next would be Bobbert. Bobbert charges a flat rate of $1,100 plus $15 per square foot. So I'll do the same thing, but now the square footage cost is 15, right? So 15 times 144 gives me 2160, and I need to add 1100 to that. Gives me 3260. So I get, for Bobbert, it costs $3,260. And then Carlisle, well, Carlisle just charges $3,300, right? Regardless of the size of the room. There's no clause about how much per square footage. It's just a flat rate, right? So who's the cheapest? Which of these three is the cheapest? Bobbert, right? Bobbert's the cheapest. Which contractor should you choose? Bobbert. She should choose Bobbert, right? Because Bobbert has the cheapest cost. Now, we've got some definitions. The first is volume. Volume is the amount of space inside of a geometric figure or an object. Volume is the amount of three-dimensional space within an object or figure. The amount of three-dimensional space within an object or figure. That is volume. Think about how much liquid would it take to fill up the object. That's volume. Surface area, on the other hand, is the outside area. Remember, area is two-dimensional, right? It's the outside area of a three-dimensional object. It's the outside area of a three-dimensional object, the surface area. Think about volume. How much paint would it take to fill the object? Whereas surface area, how much paint would it take to cover the object? Different things, right? If you think about let's say you have a cup, right? You got a cup here. You know, pretend I have a cup. You want to fill it with paint versus you want to paint the outside of it, right? Those would be two different measurements, right? Volume and surface area. Volume is units cubed. It's three-dimensional space. So, for example, it would be meters cubed, right? That's how volume works. It's cubic units. Surface area is an area. It's going to be meters squared, right? It's going to be squared units. Feet squared, meters squared, inches squared. Now, let's look at some formulas of these. We're going to deal with four basic geometric figures, and we're going to sketch them here so we get used to drawing them. The first one is the rectangular prism, more commonly known as a box. So we'll draw a box. Not too shabby of a box. Now a box has three measurements: a length, a width, and a height, right? It's got three different measurements. Now, this side length, this side length, this side width, this side height, this side height, this side width, right? There's some symmetries to a box, right? Now, the formulas for a box: volume is length times width times height. You just multiply the different dimensions together. And surface area is 2 length width plus 2 length height plus 2 width height. And this formula should make sense. Look at this square or rectangle here. It's length times height, right? Length times height. The back side also has that same side, right? And then we have, let's see, a length times width would be the bottom and the top. And then width times height would be the left and right side, right? So this covers the front and back. or sorry, this covers the top and bottom, this covers the front and back, and this covers the left and right sides. And that gives you the surface area. And then volume is length times width times height. The next shape we'll be working with is a sphere. And spheres have one measurement, and that's a radius. Just like with a circle, radius and diameter are used interchangeably when talking about spheres, but we need to know the radius for the formulas. Because the volume for a sphere is 4/3 pi r cubed. 4/3 pi r cubed. That's the volume for a sphere. The surface area for a sphere is just 4 pi r squared. 4 pi r squared. And that's for spheres. A lot of times you might say a ball or a something like that, right? We might use other words, like we say box, might say ball. Really, rectangular prism, sphere. The next shape is a cylinder, which has a circular top, and then it's like a kind of a tube shape, and then it's got a circular base, right? But you wouldn't be able to see that backside. So we dot it. And then the measurements, the circles will have a radius, right? And then the shape itself will have a height. Now the top circle and the bottom circle are the same size, right? That's what makes it a cylinder, right? Think of it like a tube, like a toilet paper tube, right? When you have to change the toilet paper, that's a very clear cylinder, right? It's got a circle on the top, circle on the bottom, and it's got a height and a radius. Now, the volume of a cylinder is pi r squared h. Pi r squared h. And the surface area is 2 pi r squared, I wanted to use that one first, plus 2 pi r h. 2 pi r squared plus 2 pi r h. And that gives us the surface area of a cylinder. The last shape we're going to be working with is a cone, which is kind of like a pointed circular object, right? It's got a circular base, but it has a pointed tip, right? Think of like an ice cream cone, right? Now, once again, there's a radius, but this time, the other measurement is a height. How tall is the cone and what's the radius of the cone? Now, the volume is equal to 1/3 pi r squared h. One-third pi r squared h. That's the volume for a cone. And the surface area, well, that's equal to, this is a little bit messy, but the surface area is pi r squared plus pi r, and then there's a square root sign, and inside of the square root we have h squared plus r squared, and then we end the square root symbol. And that is the formula for surface area of a cone. Notice the shapes have a wide range of formulaic difficulty, right? The box and the sphere, not so bad. The cylinder and the cone get a little trickier, right? And that is going to make sense, right? Think about pretty easy shape to construct, right? If you're trying to build a box, just, all 90 degrees, you make sure opposite sides are the same length. Trying to build a sphere, a little bit trickier. Trying to build a cylinder, a little bit trickier. Trying to build a cone, a little bit trickier. It makes sense that the formulas match the difficulty in constructing the objects, right? We can think about the objects themselves to understand the formulas also, right? So these will be useful for us to know because we're going to want to work with these four shapes here. Now I'm going to label them 1, 2, 3, and 4 so we can walk through each one. We're going to find the volume and surface area of each one. We're going to do each example. So number 1, the box. Volume is length times width times height. Well, the length is 4, the width is 5, and the height is 10. Well, 4 times 5 is 20, times 10 is 200. All the measurements were meters, right? And it's volume, so it'll be meters cubed. Volume will be meters cubed, right? Now, that was my volume of my box. What about my surface area of my box? Well, the surface area formula is 2 length width plus 2 length height plus 2 width height, which will be 2 length times height, 4 or length times width, 4 times 5, plus 2 length times height, plus 2 width times height, right? Let's see. 2 times 4 is 8, times 5 is 40, plus, let's see, in the second one I get 2 times 4 is 8, times 10 is 80. And then in the last one I get 2 times 5 is 10, times 10 is 100. So I did my multiplications, right? I multiplied each of my values here. Let's see, 40 plus 20 is 120, 40 plus 80 is 120, plus 100 is 220. And this was meters again, but it'll be meters squared for the surface area. The surface area of my box is meters squared. So I got the volume, and I got the surface area. And that was for the box. Now, let's try the cylinder. We'll do the same thing. We're going to take our formulas. Notice it already gives me the radius, right? And it's always good to double check. They're both centimeters. Always double check your units, right? Volume equals, let's see, for a cylinder, it's pi r squared h. Well, pi is 3.14. R is 8, and that'll be squared. Let's see, h is 15. Let's see. Now, we can use our calculator here. Let's see. We got to do squared first, right? I got to do 8 times 8 first. That gives me 64. And then 64 will be multiplied by pi and 15, right? If I'm looking at my multiplications, I've done the squared already. I got to multiply. Times 3.14 times 15 gives me 3014. 3014.4. It was centimeters, and it's a volume, so it'll be cubed, right? Volume is always cubed. So this has a volume of a little over 3,000 cubic centimeters. And that is my cylinder. It has a volume slightly over 3,000 centimeters. Now, the surface area. This formula is 2 pi r squared plus 2 pi r h. Well, I'm going to plug in 2 pi is 3.14, r is 8, and that's squared, plus 2 pi is still 3.14, r is 8, and now h is 15. Now, I need to figure out the multiplications before I add, right? In the first one, I will do 8 squared first. 8 times 8 is 64. And then I need to multiply it by pi and 2. Well, 64 times pi times 2 gives me 401.92 plus. So I did my first one. My second one, I got to do 2 times pi times 8 times 15, which gives me 753.6. So I multiplied first, and I multiplied my second. Now I can add them. We add after we multiply, right? Plus 401.92 gives me 1155.52, and its surface area. It's surface area, so it'll be centimeters squared. Square units for surface area. Now notice, in my first example, my surface area was a larger number. In my second area, my volume was a larger number. There is no way to know when looking at a given object without calculating which number will be larger. And you actually shouldn't be comparing them because they have different units, right? This is cubic centimeters, this is square centimeters. Those units are not the same. So be careful with thinking, oh, volume is always bigger or surface area is always bigger. It's not. You have to calculate both of them. Let's move on to the cone. Number 3, the cone. The volume for a cone is 1/3 pi r squared h. Well, let's see. We need 1/3 pi r squared h. Well, 1/3, let's see, pi, 3.14. R is 2, right? But 2 squared is 4, right? We're going to be squaring it. And then we need h. H is 8. Well, let's see here. What's 2 squared? It's 4, right? I want to put a little 4 under here because I just need to multiply, right? I need to do 1/3, which is 0.333333333, right? Times pi times 4 times 8. Gives me 33.5, right? We're going to round. 33.5. This was in inches. And I'm measuring a volume. So it'll be inches cubed. Now, for surface area, the formula is pi r squared plus pi r square root h squared plus r squared and my square root symbol. So let's plug in pi 3.14 r squared 2 squared plus pi 3.14 times r, which is 2, and then square root of h squared, which is 8 squared, plus 2 squared, and that'll be all square rooted, right? Now, before I can do anything, I have to figure out what's going on with my exponents. Now, square roots are like exponents, right? I got to figure out what's going on in here. Well, let's see. 8 squared, that's 64, right? 8 times 8 is 64, and 2 squared is 4. So those will add up to 68. So I did a little bit of scratch work here, because this square root symbol will be square root of 68. So 68 square rooted gives me 8.2462112. Now I'm going to write the problem down again. Let's see, 3.14. 2 squared is 4 plus 3.14 times 2, 3.14 times 2. Now, I got to the square root part, which is where I need this bit of an ugly number, right? We'll put 8.2462 112. Now, notice I'm not rounding the number because you always want to round at the end. You want to round when you finish the problem. Don't round on the in-between steps. Now, I need to do my multiplications. Let's do this one first because I already have that decimal in my calculator. So we need to multiply it by 2 and pi. So times 2 times 3.14 gives me That'll be plus 51.7862. Sorry, my calculator was off screen. 51.786205 when I multiply these three numbers together. Oops, sorry, I don't need that parentheses. Now, the first one was 3.14 times 4. Let's see, 3.14 times 4 gives me 1256. So I'll put 12.56 down. Now I need to add these. 12.56 plus 51.786205 gives me 64.35. I'm going to round 64.35. I'm going to round to 2 decimal places. Obviously, if the question said you needed more or less, you would round appropriately, right? And this is surface area. Surface area, right? That's what we were calculating. It's been a bit since we started, but it'll be inches squared for the units. So that's the surface area. And this was the volume for my cone. Notice the cones are a little bit trickier, right? The formulas take a few steps to work through, but you always want to do your square root first. Figure out what's going on inside the square root first. Work out the square root part first. Now let's go to our last one. We've got our sphere, and we've got its radius. It's 2.2. So for number 4, let's see. The volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. Let's see. 4/3 pi is 3.14. And r was 2.2, right? 2.2. 2.2 cubed equals, well, the first thing I'm going to do is the cubed part. So I'll have 4/3 times pi times, I need to do 2.2 cubed. So that'll be 2.2 times 2.2 times 2.2, which gives me 10.648. 10.648. Now I can multiply, right? 4/3, 4 divided by 3 is 1.333333, right? So 4/3 times pi times 10.648 times 10.648 gives me 44.58. Let's say 44.58 to 2 decimal places. And this was centimeters, and it's a volume, so it'll be cubed, right? We were measuring volume. Volume is always cubed. Now, the last one we need to do is the surface area of the sphere, and that formula is 4 pi r squared. Surface area of a sphere is 4 pi r squared. Now, let's take a look here. Let's plug in. 4 times pi is 3.14 times r is 2.2 squared. Well, I'll do the squared first, right? 2.2 times 2.2. When I square, I get 4.84. And then I need to multiply that by pi. And multiply that by 4. It gives me 60.79. 60.79. And that was centimeters. And it'll be squared because it's surface area, right? Surface area is always squared. So, we just used each formula to calculate the volume and surface area of our 4 different shapes here. Notice some of them are easier than others, right? Like volume of a box, pretty straightforward. Surface area of a cone, a little bit more calculation heavy, right? However, just walk through the formulas and compute them, right? Once you've plugged in, it's always the same formula. If you've worked with 100 cones before, the 101st cone is the exact same. The trick will just be getting used to the formulas, right? You got to get used to using these formulas. So make sure when you're practicing on the homework, you're getting used to these formulas. Now, let's do a couple more real-world type examples. And the first one says, Carrie Walsh Jennings wants to replace the sand in her volleyball court. So that's the background. The court is 30 feet wide by 60 feet long, and she wants the sand to have a uniform depth of 18 inches. She knows the sand costs $27 per cubic yard. Okay, so I'm going to need to use yards eventually. How many cubic yards of sand does she need? Well, I need to be careful. My measurements were feet, and inches. Now, I've got a width, a length, and a depth, which could also be thought of as a height, right? If I think about a volleyball court, it's rectangular, right? And we said it was 60 by 30, and then the height would be 18, right? If I wanted to add the third dimension. And I need to be careful because these were feet, and then the height was 18 inches. 18 inches. So I need to convert all of these numbers into yards first. Well, first, 18 inches. How many feet is that? Let's get all the numbers in feet first. 18 inches. I'm going to put it over 1 inches, and I want to put it to feet. There's 1 foot to 12 inches, right? Then, once I have it in feet, I want to cancel out feet and get to yards, right? We're doing dimensional analysis. We're converting units, right? And remember, 1 yard is 3 feet. So when I multiply, I'll cancel my inches and I'll cancel my feet, and I'll be left with my desired yards. In the top, I have 18, right? 18 times 1 times 1. And in the bottom, I have 12 times 3 is 36, which is yards, which is 0.5 yards. Half a yard. 18 inches is half a yard. 0.5 yards. Now, I'll have to do the same thing for 30 feet. Over 1 times, I want to cancel feet and be left with yards. Well, once again, there's 1 yard to 3 feet. We'll get 30 over 3, which is 10, right? 30 divided by 3 is 10 yards. 30 feet is 10 yards. 60 feet is twice that, right? 60 feet is twice as long. So if you do the same work, you'll see that 60 feet is 20 yards, right? That's some Chapter 7 stuff, right? We're converting units. You want to be comfortable going back and forth between units because we needed everything in yards. We needed all of our values in yards because the question's asking us for yards. So for part 1, how many cubic yards does she need? So I'm looking for volume, which will be length times width times height, which is equal to, let's see, length is 60, or sorry, we're using the yards measurements. Length will be 20, right? Width will be 10, and the height or the depth will be 0.5, right? So let's see, 20 times 10 is 200, times 0.5 is 100, right? It'll be 100. 20 times 10 times 0.5 gives me 100 yards cubed. The volleyball court is 100 cubic yards. So that's part 1. Part 2 says how much will the project cost? Well, it's 27 bucks per cubic yard. Well, that's going to be 27 bucks times 100 cubic yards, right? Will be 2,700. So it'll cost her $2,700 to fill the volleyball court with sand. Notice we had to do unit. The tricky part about this question wasn't necessarily the calculations. Volume was pretty straightforward. Price was pretty straightforward. The tricky part was getting everything in the same units. Now, the Baseball Hall of Fame in Cooperstown, New York, wants to erect a statue of a gigantic baseball. They're trying to build a big baseball. What shape's a baseball? I'm going to draw right away. It's a sphere, right? It's a gigantic baseball. The statue will have a diameter of 8.5 feet. 8.5 feet. Determine the surface area of the statue. And then, if 1 quart of paint covers 100 square feet, how many quarts of paint will the painters need to purchase in order to paint the baseball? Well, let's take a look. We're looking at a sphere. Now, I wrote R here. I need the radius. Remember, the radius is always half the diameter. 8.5. If I take half of that, that's 4.25, right? 4.25. So the radius is 4.25 feet. So for part 1, the surface area for a sphere is 4 pi r squared. 4 pi r squared, which is going to be 4 times pi is 3.14 times r squared, which is 4.25 squared. Let's see, we got a square first. 4.25 times 4.25 gives me 18.0625. Let's see, I got to multiply that by pi times pi, and then I got to multiply by 4. It gives me the surface area is equal to 226.865, and the measurements were in feet, and it's going to be square feet because it's surface area, right? Surface area is always squared. So the surface area of my statue is 226.865 feet squared. Now the second part gives me a ratio, 1 quart to 100 square feet. So let's see, 1 quart covers 100 feet squared. Let's see, for the second part, right, I want to know X quarts will cover, well, my baseball is 226.865 feet squared, right? We have a proportion problem. We're trying to figure out the number of quarts to cover our baseball. So I can cross multiply. I'll get 226.865 this way and 100x the other way. Divide both sides by 100. Will leave me with x equals 2.26865. 309, right? 2.26865 quarts. Now, can I buy 2.26865 quarts? Maybe. It depends on how I'm buying the paint, right? But you might need to buy 3 full quarts, right? If you can only buy the paint in whole jugs and each one's a quart, you might need to buy 3 full quarts, right? Because 2 wouldn't be enough. So that's another real-world example. We have a baseball we're trying to paint. A gigantic baseball, but we're still trying to paint it, right? So here we had to calculate the size and then use a proportion to get our actual value. Now, in our last example, Old MacDonald has 3 silos on his farm. E-I-E-I-O, right? Old MacDonald. The silos are each constructed in the shape of a cylinder. Alright, so I'm working with cylinders. One silo has a diameter of 12 feet and is 40 foot tall. One's 14 feet by 50, and one's 18 feet by 60. What is the total capacity of all 3 silos in cubic feet? Well, it's good all of my measurements were in feet, so I don't have to do anything with that. And then part 2, we'll deal with that in a second. Let's look at the first part. First, volume of a cylinder is pi r squared h. I'm going to need to write that down. We're all cylinders here, right? And let's see, we have a cylinder with a diameter of 12 and a height of 40. The second one, we'll use blue for this one. And the third one, we'll use the Sharpie. We've got 3 different cylinders we need to work with, right? So we'll do the red one first. We'll label it volume. I'm going to put a little 1 next to it so I remember it's the first silo. Let's see. It's pi 3.14. Radius. If the diameter is 12, the radius is 6, right? Radius is always half the diameter. And then the height would be 40. Now, I'm going to also calculate the second one at the same time. I'm going to do all my formulas. I'm going to write them all out at the same time. This one, we'll use the blue marker, or the blue pen. Let's see, it's going to be pi 3.14 times the radius. I was given diameter again. 14-foot diameter would be 7 feet for the radius, right? It's always half. And it was 50 feet tall. And then for the third one, the volume of the third cylinder, we'll use the Sharpie for this one. 3.14. Let's see. The third silo has an 18-foot diameter. Once again, I need half of that. That'll be 9 for my radius, right? And that'll be squared times the height, which is 60. So I've got my 3 different volumes. The first one, you always start with the squared. 6 times 6 gives me 36. And I got to multiply that by pi and 40. 36 times pi is 3.14 times 40 gives me 4521.6. And everything was in feet, so this would be feet cubed. It's feet cubed because it's a volume. Volume is always cubed. Let's see. For the next one, we'll do the same thing. We'll do 7 squared first. 7 times 7 is 49 times pi and times 50. It gives me 7693 feet cubed. 7693 feet cubed. And then we'll do the same thing for the last one, right? We'll start with 9 squared. 9 times 9 is 81 times pi, and then times 60 will give me 15260.4 feet cubed. 15260.4 feet cubed. So, I have the volume of my 3 different silos. So the total capacity, maybe the total volume, right? Capacity would be volume. What's the total amount of stuff I can fit in the 3 silos? Well, I could find the total volume by adding together my 3 other values, right? I can do these 3 numbers added together. The total capacity will be the sum of the other 3, right? It'll be V1 plus V2 plus V3, right? If I add my other volumes together, I should get my total capacity. Well, let's do it. We've got V3 is 15260.4 plus 7693 plus 4521.6 gives me 27475. 27475 feet cubed. 27,475 feet cubed. So the total capacity is about 27,000 cubic feet, right? A little bit more than that. Now, we haven't looked at the second part. So, if McDonald fills all 3 silos with feed for his pet pigs, and then feeds the pigs 150 cubic feet of feed a day, how many days will it take for the silos to be emptied? So this is another proportion, right? It gives me a ratio. 150 feet cubed feeds the pigs for 1 day. Now, I'm asking about how many days will my whole silo Feed. Well, my whole silage, all of my storage for my silos, right? That's called silage. How much will it feed? Well, we're cross multiplying. We get 150 times x equals 1 times anything is itself, right? 27,475. Well, with proportions, we always divide by 150. Gives me x equals, let's see, 27,475 divided by 150 gives me 183.1666 days. So, on the 184th day, the silo will be emptied, right? Because after 183 days, I'll only have a little bit left, right, as a decimal. So on the 184th day, the silos will be emptied. So he can feed his pigs for just shy of 184 days. Sometime during the 184th day, his pigs will run out of food, right? So he'll want to make sure he plans accordingly, right? It's about half a year almost, right? 365 days in a year. 184 is a smidge more than that. So twice a year he'll have to fill his silos, give or take, right? And that is our last example. Thank you all for stopping in, and I will see you next time.